Hi, this is Koiro. I recently did a video on making a -5-volt regulator to use on an adapter for connecting an ATX kind of power supply to an AT kind of computer, or you can use the same to provide -5-volt to an ATX if you want. So that's why we made this simple 7905 circuit to fix this problem. But the question I get is, why bother? And the short answer is because it's really part of the ISA specification and it is supposed to be there. And it's an heritage from the first XT bus that was made by IBM when they introduced the first XT. And it was removed because it was never part of the PCI bus specification. So that's the short answer. So that's okay? Not really. The standard was changed in 2002 as the -5-volt became optional. That means that there are systems out there with ISA buses that has no -5-volt rail. But when the ISA slot went the way of the Dodo and the PCI Express became the new king in town, it was game over for -5-volt for good. And on the new 2.0 ATX power supply connector, this is marked as not connected. But the reason I did this is to test my Pro Audio Spectrum sound card that really needs the -5-volt. And I will try to explain here what this is all about. If you don't have the -5 rail available when you input sound or other analog inputs to your computer, you really don't have much in the way of playroom for your signals to go. You have the space between 0 and 5 volts. And if you also have the -5-volt rail, you can extend this room to be about 10 volts that you have to play with for making audio signals. And that means that you can use symmetrical instead of asymmetrical op-amps and other circuits to amplify and modify your signal. And as you will see in this example that I'm drawing out here for you, it is really a matter of making this a better audio device. The sine wave that we are drawing here is amplified, and this is an ideal circuit that we describe on top, and ideally this should work, and the signal will have about 2.5 volt as the zero line that it swings around. A symmetrical circuit like you see here, you have a much larger playroom and you're not exploring the extremes to the same degree as you do in the other example, where you only have about 9 to 5 volts to play with. And you also have much more power available to your amplifier in the output stage because you have 10 volts instead of 5 volts available. So the example in the top is an ideal world, and the example in the middle here is the way the Pro Audio Spectrum and the Sound Blaster 2.0 solves this problem. But we will see here what happens in the real world as we will try to make an example for how this will look when you input a signal in a normal circuit that's within the boundaries of a 5-volt logical level. When you try to, with the limited available space between 0 and 5 volt, you will reach the boundaries where you have the levels that's close to 0 and close to 5 volt. And that will be without the liner part of the amplifying circuit, as I will try to show you with a really easy transistor graph on the next drawing. But as you will see, any flaw in the input will amplify itself to a much larger error on the output, of course. And this will make the sound much more harsh and unpleasant sound than you will have if this was done with a symmetrical signal. So this is how it looks in a not so ideal world. It's a real world example. And the reason why you are not able to get a good signal on the lower and higher part of the signal close to 5 volt is because the graph that represents the transistor input is not linear. So when you try to impose a signal on this, you will have the topmost and bottommost part of the graph that's not linear, and that will make distortion in your signal. The way the Sound Blaster 16 and other sound cards solve this, they don't use a symmetrical power input at all. They use the 0 to 5 volt rail. But on the input stage, that's less of a problem because you can live with that kind of distortion that you get on the input, because the input signal on a typical line level is either 1 volt peak to peak or 2 volt peak to peak maximum on a line input. And within those boundaries, it's possible to do it between 0 and 5 volt. But what they do is they use a step-up power supply and use a symmetrical design amplifier via a switch mode or a charging pump to get a higher voltage on the output. And to chop up the signal for making this, you will get some frequency and disturbances in the signal. And I try to illustrate that here by drawing these small inaccuracies in the sine wave. And this will be the noise level that the Sound Blaster 16 and some of the other clones and other Sound Blaster cards are riddled with. It's because it's really much noise introduced in the analog part of the signal. And it's partly because of the step up in the amplifier circuit, and it's part of because it's not handling the noise from the bus very well. And of course, if you have 10 volt signal, you have a much better chance of getting a good signal to noise ratio than if you try to do everything within 5 volts. The minus 5 volt was introduced on the IBM XT, and the reason why it was introduced was in the old days, when you have the 4116 memory chips, you really had 3 power rails connected to every memory chip. It was the minus 5 volt for BIOS, and it was 12 volt and 5 volt for the logical level. And this really stopped with the 64 kind of memory, like the 4164 and the ones we've seen in Commodore 64 or other similar computers. And you also had the EEPROMs, the 2708, that was a common chip back in the day. It uses the minus 5 volt. What really happened was that they made this BIOS internal to the memory chip via a charge pump circuit. Some old networks card also used the minus 5 volt. Probably there was some modems and other stuff that was in the delta between audio and communication devices. The original IBM floppy controller also used minus 5 volt, and I also seen some cards that do control logic and measurement logic for lab equipment and other stuff that uses the minus 5 volt rail. But this was not cards that was common and used much in the workspace. It was lab cards, really. So the simple truth is that the Sound Blaster 2.0 and the Pro Audio Spectrum line of cards is the only cards, some other sound cards too, requires the minus 5 volt rail, but not much else. So if you omit this, it probably won't matter for you. And the Sound Blaster 2.0 and the Pro Audio Spectrum was among the best cards when it come to the signal noise ratio and noise introduced into the sound in the cards. And as we have seen, that is not a coincidence. The superior circuit that you could have to tap into the -5 volt probably made a difference. So, do you really need it? The answer is probably not. As you will see here, this is 4 sound cards and only one of them actually has the -5 volt rail connected at all. The -5 volt is the pin number 5 when you look on the back side of the card from the back plane. But what happens if you connect your Sound Blaster 2.0 or your Pro Audio Spectrum to a computer that does not have the -5 rail present? The card will as such work, and the ISA bus and everything logical on the board will work without the -5 volt rail. But as we saw in the start, the audio circuits depend heavily on the -5 volt. So what really happens is that everything below 0 will be, it will be emptied out, and you will get only half the sound. And it's really no way of describing this, because it will sound different for every instrument and every kind of sound. But of course the sound will be heavily disturbed. So that's why you need it for audio cards, and why I made this circuit and placed it on my test rig. The -12 volt rail is still with us today, and the main reason that we still have it is that it heavily tied to the RS-232 or V24 or other communication standards that needs a symmetrical signal. And of course it's possible to have a charge pump or a small regulator on the main board and only supply the main board with 12 volt, and that will probably be what's happening in the future, because the power supply themselves will be cheaper if they only supply one rail of power, and it also means that the circuit and cabling inside it's much cheaper. So it probably is just a matter of time before the specification will be so that you only supply 12 volt to a motherboard, and all the other supply voltages that you need will be supplied via the motherboard. And this is a factor that's also driven because now we have SD cards in the form of M2 and PCI Express slots, where you don't have any power leads at all to run external equipment. And if you don't need 5 volt or 3.3 volt for hard drives or other stuff, it's no good idea to have the power supply them anyway. But why don't the sound cards use the -12 volt? And the answer to that is that the -12 volt rail does not have much power to offer, and it also will be a higher power circuit because you have 24 volt as a delta. But it's possible, and some have even tried to connect the -12 volt to a sound card to the audio circuit and actually have it working, but that is no recommendation for me, so don't try that at home. So thanks for watching. Please subscribe if you want to be notified when I publish another video, and I really appreciate it if you make a comment below if you have some opinions about my videos. See you in the next one.